The world we're building in Miyagakure is a world in which there are 4 spatial dimensions instead of 3. In this game, the 4th dimension is not time, but the 4th dimension of space that works just like the first 3 dimensions we're familiar with. If you count time, this game is 5D. In this video, we'll talk a little bit about the unique technology we developed for the game. So, at first games were only 2D and only took place along 2 directions. Then computers became powerful enough to render 3D graphics, and this allowed for full 3D movement. Of course, the graphics we see while they are computed in 3D are actually displayed on a 2D screen. They are projected down from 3D to 2D in a way that mimics how our eyes perceive the 3rd dimension. But it doesn't stop there. If in a 2D game every object's position is represented in a computer using 2 numbers, and if in a 3D game every object's position is represented using 3 numbers, what if each position was represented using 4 numbers? In other words, what if there was another direction you can move along in addition to the first 3? Trying to answer this question is what led us to develop this game. However, as far as we know, our universe has exactly 3 spatial dimensions, so it's difficult for us to picture what a 4-dimensional world would look like. But a computer, on the other hand, does not care. It's just working with numbers as usual. So we had to come up with a way to display this calculated 4D world so that our 3-dimensional brains could comprehend it. The way we chose is a method that has been popularized in the novella Flatland. This novella talks about a 2D square that can only see a 2D cross-section of a 3D world. For the square, the 3rd dimension is invisible and mysterious. The square has no concept of it because it is stuck seeing a 2D world. If a 3D object visits the 2D plane, it appears to be deforming. In Miyagakure, a similar process happens, but in one higher dimension. Instead of taking a 2D slice of 3D objects, we are taking a 3D slice of 4D objects. It's hard to imagine, but luckily we don't have to. A computer can just display it for us. But how to build a 4D world and the objects that populate it, especially without being able to fully see them? In a 3D game, objects are usually made out of triangles. The surface of a 3D object is 2D, and triangles are the simplest 2D shape. To generalize this concept, we add a dimension. The surface of a 4D object is 3D. So what is the simplest 3D shape? It's a pyramid-like shape called the tetrahedron. So to build the surface of any 4D object we want, we can use the tetrahedron as a building block, and that's what this game does. What happens is that, instead of projecting the tetrahedra on the screen like we're doing now, we slice them using the 3D plane that represents what the player can see. That gives us a bunch of triangles, which we then draw the same way we would draw them for a regular 3D game. What you see is a 2D projection of a 3D slice of a 4D object. But how do we even create 4D objects? We can't easily visually manipulate them using a 4D equivalent of Maya, but what we can do is generate them procedurally. So let's take a simple example. To build 4D crystals, we use a method similar to how we would build a 3D crystal procedurally, but instead of starting with a 2D hexagon and extruding it up, we start with a 3D dodecahedron and extrude it into the 4th dimension. I picked the dodecahedron because it often gives hexagons when you slice it. Surprisingly, in this scene, every crystal is the exact same shape, only facing different directions and slightly longer or shorter. And yet they all look so different because you only see a slice of each of them. This is particularly interesting because of the known connections between high-dimensional space and certain crystal structures. I can move a little bit in the 4th dimension and the scene will look slightly different, and again, slightly different. There are technically an infinite number of unique slices one could take. Here is another more complex example. The surface of this 4D shape, called the 120 cell, is made out of 120 dodecahedra. In this case, I cut a hole inside each dodecahedron to make them hollow. While you could ignore all this when playing the game, to me it feels even more beautiful when you know more about what is happening. I wanted to share some of the things you may not realize when you finally get to play Miyagakure.